Okay, guys, let's review our quadratics as a graph and also as an equation and learn how to identify the key features. Then we're also going to convert quadratic equations from standard to vertex to factored and so forth. So the first thing we're going to take a look at is a graph of a quadratic, which is a parabola. We also have the equation. So because we are given a graph, identifying the key features is going to be a bit easier than when we do not have the graph. So our A value is -1. So because it's negative, our parabola opens down. Obviously, we can see in the graph it opens down. Our vertex is 3, 4. So we write that as an ordered pair. Our AOS is this vertical line that divides the parabola into two congruent parts. So this is the line x equals 3. Our roots are the x-intercepts, and we list those as elements from least to greatest. So that's 1 and 5. Those are also called the zeros or the solution. Our y-intercept is the ordered pair when x is 0, so 0, -5. This is when it goes through the y-intercept. Our domain is -infinity to +infinity. Remember, domain are your possible x values. The range is the possible output. So our possible outputs go from -infinity, and then it goes up to 4, and that 4 is included as part of the range, so we need a bracket. Our interval of increase is going to be on the left side of the AOS, so our graph increases from -infinity up until the 3. So that's the area in which our graph is increasing. And then from 3 to +infinity, our graph goes down, it decreases. Our end behavior as x approaches -infinity, so that just means on the left side of the graph, the end is going down. So on the left side, the end of the graph, f of x, approaches -infinity. And then as x approaches +infinity, as the x values approach +infinity, f of x approaches -infinity. This end of the graph goes down as well. Now we are going to find the AROC over the given interval 0 and 2. So really, this is like finding the slope given 2 points, and they always will give you the x values of the two ordered pairs. So when x is 0, y is -5. When x is 2, y is +3. So these are the two ordered pairs. But we can simply just count rise over run. So this secant line has a rise of 1, 2, 3, 4, 5, 6, 7, 8, a rise of 8, and a run of 1, 2. So 8 over 2, or simply 4, is the AROC over this given interval. Okay, now we have just the equation, and we're going to answer all of these key features. So I'll probably be going back and forth between colors. Okay, so our A value is 1. It's positive, so we know the graph opens up. Our vertex, so the vertex, okay, is H, K. This is your X and your Y value. So the formula is X equals -b, so we have a negative from the formula. Our b value is 6 over 2 times the a value. So we have -6 over 2, which gives us -3. So the x part, or the h, those are interchangeable, is -3. That's also our AOS. Now, to find the y part of your vertex, you plug in the value of x, which in this case is -3, into the equation. So when we plug in -3, we always use parentheses. when we are substituting in a value. So we have -3 is x squared plus 6 times -3, and then plus 5. So carefully use order of operations. When we square a negative, we get a positive. Then we have -18 and then plus 5. When we combine our two positive numbers, we get 14 minus 18. So our output, y, is going to be -4. So our vertex is -3, -4. So let's do a sketch. So -3, -4 is somewhere here. Our graph turns up, so we do know that we will have two real roots. We will have two x-intercepts. So it's a good idea just to test to see if the parabola will pass through the x-axis at all. So to find the roots, you can always use the quadratic formula, but first I like to see if the quadratic can be factored easily. So I'm going to use there's no GCF, so I have a times c goes on top, my b value is on the bottom. We're saying what times what multiplies to give you 5, but adds to give you 6, so that's going to be a 5 and a 1. So we can write this function in factored form. Our a value is the understood 1, then we have x plus 5 and x plus 1. To find where they cross the x-axis, we set each of these equal to 0. So we have x plus 5 equals 0. We have x plus 1 equals 0. When we solve for x, we subtract to isolate, and one root is -5. The other root is going to be -1. So our roots from least to greatest are -5 and -1. Our y-intercept is when we plug in 0 for x. So when you plug in 0 here and here, we are simply left with our c value of 5. The domain is going to be all real numbers. And our range, it goes down to the y part of our vertex, which is -4. That is included. And then it goes up to positive infinity. Interval of increase and decrease. So let's sketch in our AOS. So this is x equals -3. So our graph increases on the right side. So from -3 to positive infinity, our graph increases. And then on the left side of the AOS, our graph is going down. So from -infinity up until -3, the graph is decreasing. Now our end behavior, our graph on the left side and on the right side is going up. So as x approaches -infinity, that's just saying on the left side, the left end of the graph is going up toward positive infinity. And then on the right side, it's also going up. With parabolas, the end behavior is always going to be the same, either both ends going up or both ends going down. Okay, now we're going to find the AROC. So it takes two ordered pairs to find slope. They're always going to give you your x values. So let's make some room here. So we are going to find the output of our two inputs and then use slope formula. Okay, I think that will be enough space there. Okay, so when we plug in -5, first I'm going to see, do I have any ordered pairs where x is -5? Actually, I do. So this root is -5, 0. So really, we didn't have to do any work. Then do I have an ordered pair where our x is -3? Yes, our vertex. So there was really no work to be done. So always check to see if you already have those output values. So here we go. We are going to have y2 minus y1 over x2 minus x1. So we have -4, keep change over +2. So the AROC is -2 over that interval. Okay, now we are going to convert some equations to the different forms. So we have here standard form. So we know the y-intercept is 0, comma, -3. Now let's factor it out to put it in factor form. Our a is 1. So we have a times c and then our b value. There's no GCF. So what times what gives us -3 but adds to -2? So that's going to be -3 and 1. So we have x minus 3, x plus 1. So this is factored form. So our two roots, if we were to set these each equal to 0, would give us -1 and 3. Now we're going to convert this to vertex form. So we're going to use standard form. We're going to find the vertex. So our vertex is the h, comma, k. So to find your h value, we do -b over 2 times a. So this gives us +2 over 2, which is 1. So this input value, x, is your h value, 1. Now to find the output, we plug it in to the standard form of the equation. So x is 1, just plug it in everywhere you see an x. Order of operations, we square the 1, multiply, and now we combine. So we have 1 minus 5, so this gives us -4. So to write it in vertex form, f of x equals our a value is 1, just like here and here. Then we have x minus the h value, quantity squared, and then whatever the k value is, -4. So now we can do a quick sketch. Our vertex is 1, -4. It's in quadrant, this is quadrant 4, and our graph we know turns up, and it goes through -1 and +3. We know that here's our y-intercept point, and then our AOS is going to be x equals -1. So our interval of increase is from -1 to +infinity. Our interval of decrease is from -infinity up until the +1. So it decreases on the left side, it increases on the right side. Our domain is all real numbers. Our range, it goes down to the -4. So range is from -4 to +infinity. When we do in behavior, as x approaches -infinity, f of x approaches +infinity. As x approaches +infinity, f of x approaches +infinity. Okay, now we're going to convert this factored form into standard and then vertex. So our roots are going to be -8 and +4. Our graph is going to turn up because we have a positive a. I like to distribute my binomials, so we have x times x, x times 8, -4 times x, and -4 times 8. Combine our like terms. And now distribute your 1/2. So we have 1/2 x squared plus 2x minus 16. So our y-intercept is 0, -16. Now we need to convert this to our vertex form. So the vertex, we take half of, so x equals -b over 2 times a. This gives us -2 over 1, which is -2. So that's also, we can go ahead and write the AOS, and it's x equals -2. Now we're going to take this value of -2, this is the x value, so we're going to plug it in everywhere we see an x. So we have 1/2, x is -2, I'm going to use parentheses so I don't have a silly mistake with my signs. -2 squared is 4, 4 times 1/2 is 2, -4 minus 16. So this gives us, this is 2 minus, looks like 20. So our output value is -18. So we're going to say f of x equals, our a value is 1/2, and it's x minus -2, so that becomes x plus 2, quantity squared, minus 18. So our vertex, -2, -18, is here in quadrant 3. Our graph does turn up because it's positive. It goes through -8 here, and then +4 here, and the y-intercept is somewhere about right here. So the graph looks like this. And our AOS is x equals -2. So from -infinity to -2, the graph decreases. Then from -2 to +infinity, the graph increases. Our end behavior, they both go up on the left side and the right side. Our range dips down, so the range is going to be -18, and it's included to +infinity. And our domain is all real numbers. Okay, this is our last one. We are given the vertex form, and we're going to convert it to standard and then to factored. So given in vertex form, we can easily identify our vertex. Remember, right here, your H value, this is H, this is K. It is always the opposite of what you see. The K, it is what it is. So our vertex is 6, 1. Now to convert to standard, we simply apply order of operations. We are going to use some grouping symbols. We're going to expand the exponent. So we're going to do the exponent first, and you have to expand it out. We are going to multiply x minus 6 times itself. Whoops. Braces, that is supposed to be 1/4. And when we multiply binomial times itself, we get a perfect square trinomial. When we distribute the -1/4, we can drop the grouping symbol, so we get -1/4 x squared plus 3x minus 9. And then we have plus 1. So standard form is this equation here, and our a value is still the same a. So now we know our y-intercept when x is 0, so 0, -8. Now we're going to factor this quadratic, so I'm going to factor out the GCF of -1/4. So when I divide out a -1/4, that is the same as multiplying by -4. So we're going to get a positive x squared, and then a minus 12x, and then a positive 32. Bring down the -1/4. We're going to factor the x squared into x and x. So we have 32 and then -12. And then we're going to ask ourselves what times what is going to give us -12. So that's going to be -4 and looks like -8. If I add these, I get -12. If I multiply, I get the positive 32. So this is factored form. Now, we would set each of these equal to 0 to find the roots. So our roots are 4 and 8. So if we were to sketch this, our vertex is 6, 1. Our graph does turn down and goes through 4 and 8, and then our y-intercept is somewhere down here. Our AOS is x equals 6. So from -infinity to 6, the graph increases, and then from 6 to +infinity, the graph decreases. Our range is going to be -infinity up until our y value of 1, and it is included. When we do in behavior, both of them approach -infinity. Our domain is all real numbers, and I hope this helps.